Our second keynote speaker is Dr. Joscha Bach. Dr. Bach is an AI strategist at Liquid AI, and he's also the director of the California Institute for Machine Consciousness. His work spans cognitive architectures, models of emotion, perception, and the self. Dr. Bach has held positions at Humboldt University, MIT Media Lab, Harvard Program for Evolutionary Dynamics, and Intel Labs. Today he will explore the mechanisms and architecture underlying consciousness itself. Please welcome.
Thank you, Christine. It's a great honor to be again in Iceland, again for an AGI conference, and very happy to talk about some thoughts that I have about one of the frontiers of our most favorite topic. What is the mind? What is intelligence? How does the mind make sense of the universe? How does it come into being? The hypothesis that I'm currently exploring is what I call the machine consciousness hypothesis, and I gave a brief talk in the workshop about the difficulties of testing for consciousness. And this machine consciousness hypothesis basically is made out of several steps. One is, you could say, the organismic consciousness hypothesis of what consciousness is an organism. And the second one is that we can recreate these conditions that exist in organisms that lead to the formation of consciousness in machines. And if both conjectures are true, it would mean that we can test the former one by building the latter, by realizing the latter. And so in this way, testing for consciousness gets replaced by an interpretation. And we can make this interpretation modular by defining the phenomenology until we are satisfied this captures this what its likeness of consciousness. We define the functionality, this is what consciousness is doing, and we can talk about how the implementation space and research would look like, and so on. But we can basically decouple these different elements. But before we can discuss things like this, we need to reach an agreement of what we mean by consciousness for our purposes. And there are basically three approaches that people can be using when they talk about consciousness. The first one is about this experience of what it's like, which we call phenomenology. And there are several aspects to the phenomenology of consciousness for me that, in the way in which I use the word, refer to what its likeness. And the first one is consciousness is always happening now, in this moment. And it also seems to be what creates the sense of nowness. So and this, what characterizes now is what's currently the case in my perception. And then there is, beyond this present, also a presence. And this is basically the second order thing that is happening, that you're not just perceiving, but you also perceive that you are perceiving. And some philosophers call this higher order thought because it's a thought about something else, but I don't think it's a thought, it's a perception. A thought is somewhat decoupled. You can hold a thought for as long as you like, and it doesn't have to relate to what's around you. A thought, in a sense, is not so much in time, but the thinking happens in real time, right? You observe yourself to be thinking because you observe yourself exerting your mental muscles in this moment. So there is a perception involved when you think. And this perception of perception, that you are noticing what's happening, that is what is the second order perception of consciousness, which gives it a reflexive tinge. And you can also move beyond that. You can have a person perspective or a perspective from a self that looks from a certain angle. And this means that you zoom a little bit further out and you integrate it to the point where you simultaneously, with the object that is being perceived and with the fact that it is being perceived, also perceive the direction from which you perceive it, right? That you have a self. And in this way, the observer can constitute itself. But this is optional. You can also have states in deep meditation or in states of dreams at night where you can experience that stuff is just happening and there's nobody present who looks from a particular direction. So there's still consciousness, but there is no self. And there's also a state where you can transcend the self, where you basically go to a fourth order perspective, where you realize that perception is itself a representation inside of your mind. And you basically get to see this interplay between the self and the thing that's being perceived from the outside, where you see how your world model is being projected into the self model, and you're no longer that self. And you realize, oh, I'm not actually Joscha Bach, I'm not that guy. I run on his brain as far as I know, but I'm just this consciousness. And this guy is a story that is being created by me about what it would be like if this organism had a name and an identity and the social things that it cares about and so on. And the other approach for consciousness that is typically being taken in the sciences is looking at the mechanisms that might facilitate it. For instance, the neural correlates of consciousness, the default mode network, the stuff that goes on in the anterior insula and the prefrontal cortex and the claustrum and so on. And also the outside perspective, looking at the mechanical interactions of the organism and its world. But it's very difficult to relate these two descriptions to each other. How is it possible that a mechanical thing experiences what it's like? And this difficulty of associating this experience, the psychological reality, with the mechanical reality that we typically look at in the sciences is called the hard problem. And this hard problem seems to be a somewhat recent problem. Most cultures don't have it. It seems to be part of our scientific culture. And I wondered whether it's something that we came up with after the Enlightenment, after we got rid of the Christian superstitions. But when you read Goethe and Brentano and so on, they're all post-Enlightenment and they don't have this issue. It seems to be a 20th century thing, where we basically forgotten how to deal with this kind of dreaming reality. And I think that there is a way in which we can make sense of it, and this is basically we look at the operation of consciousness. Consciousness is an operator on mental states. But your mental states are representations that you hold in your mind. You yourself are a representation in your mind. You're interacting with other representations dynamically. And consciousness is an operator that changes the content of your mind when it comes along. And so we can ask ourselves, how do my mental state changes when consciousness happens? So, for instance, between deep sleep and waking up, what changes? And what changes back when you space out and fall asleep? And what happens when you have an epiphany? And this operation of consciousness is something that makes us more coherent, and we can observe that. And when we look at the philosophy of mind, we do have a number of approaches that talk about the big difficulty of dealing with the hard problem. There are a lot of angles in philosophy, for instance, the position that maybe consciousness does not actually play a causal role because it cannot be explained mechanically in its interaction with the world, and actually it's plausible that an organism does everything that we observe ourselves to be doing without consciousness. And this idea that consciousness has no causal role is called epiphenomenalism. And the problem with epiphenomenalism that consciousness is basically only observing what's happening and cannot actually trigger anything in the physical world. So it can be in a separate dualist domain that is separated from the physical universe and does not impinge on it. The difficulty with this position is that the epiphenomenalists, in order to tell us that they are an epiphenomenalist, need to move their mouth or their fingers on a keyboard or something, right? And this movement in the physical world is not caused by them being conscious. It's just a mechanical act that is unrelated to whether they're conscious or not. So the problem is, if an epiphenomenalist tells you that their consciousness is not impinging on the physical world, you don't need to listen to them because it's unrelated to whether they're conscious or not. Another position is that consciousness is happening in the interaction between a body and an organism, and it's not representational, it's not mere computation, there's something else going on, it's the touch with the mystical reality substance that makes you conscious. There is the general idea of the mind-body problem that gets seen as central. There's the position of Mysterianism, which says that consciousness is outside the realm of being understandable by our minds. There's no way in which we can make sense of it. Even if an explanation exists, we would not be able to fit it into our mind. Then there's illusionism, which says that consciousness doesn't actually exist, and we only need to explain why some people claim to have it. Then there's panpsychism, which says that consciousness is basically in everything, and it somehow can be explained just by being an intrinsic property of matter, and just correlates in the organisms and expresses itself. Then there's the idea that consciousness is primary, and the physical world is just a figment of the imagination of consciousness. And then there are ideas that say, oh, we need completely new physics to understand consciousness somehow. But there are also a bunch of theories that converge. For instance, Plato himself, who is usually credited with inventing idealism, if you read his theories, he was not actually an idealist in the sense that he believed that the consciousness is primary or mental experience is primary, but it's the starting point. Right? Plato talks about these ideal forms, but these ideal forms, there's, for instance, the ideal form of a table is sometimes given as an example. And that's probably not some of the core archetypes of the universe of God itself, but tables are created by human beings, in particular cultural contexts, and they are an archetype in our perception, right? The way in which we classify the world, there is something like an ideal table. And so actually the forms that Plato is talking about that are admixtures when we create thoughts and so on are actually dimensions in an embedding space. And I suspect that Plato is the first guy who wrote about the embedding space that we discovered much later in AI. And he, in some of his texts, alludes to a world outside of our perception, outside of this mental construction that we experience. And that world is an outside simulated world that is isomorphic to the world that we experience in these forms. Then as Aristotelianism, basically Aristotle says that the world is physical, mechanical, and it's a mathematical object at the lowest level, the logos. And then on top of the physical world, you have software, you have forms that shape dynamically how the world is working. And this is what Aristotle calls the soul. Then we have computationalist functionalism, which is basically the position that we can describe arbitrary systems using constructive languages, which means using computation. And functionalism means when we talk about objects, how did we get to these objects? Well, we constructed them over the observation of behavior, over functions. And so it's a position that allows us to make sense of how we model reality and by extension also the mind and consciousness. Or virtualism is the idea that consciousness is not a physical object, it's not a mechanism, it exists as if. And by existing as if, it becomes real because it has causal power on the world and thereby instantiates itself. And it's this idea of a Cartesian theater, global workspace theory, attention schema theory, consciousness being a model of our attentional control and so on, adaptive resonance theory that explains it as some kind of resonance between neural activation states. And all these theories are basically aspects of blind people touching the elephant from different sides, but in a way that fits together. And so there is a convergence of theories. And this, to get back to this machine consciousness hypothesis, to me it has basically two aspects. The functional nervous system hypothesis, which says that consciousness is a causal pattern that forms in brains and facilitates attentional learning and how we coherently model the world and so on, and agentic control. And the way in which consciousness works automatically leads to phenomenology, and we should explain why that is the case. And then the structure of consciousness is induced by self-organization in the brain. And the machine consciousness extension says, okay, when we understand consciousness in this way, if the theory is correct, then initially we might also be able to induce the same principles of self-organization on the GPU maybe. And then if we observe consciousness to emerge on the GPU, this would test the first hypothesis or validate the first hypothesis. What is the role of consciousness in the mind? So the way in which I usually characterize it is this cortical conductor, that you are the maestro of your mental orchestra, and this mental orchestra is made out of lots of instruments that basically make up processing streams, roughly every brain area corresponding to an instrument in the mental orchestra, and they all play their different parts of the melody of the mind. And whenever there is incoherence in there, your consciousness steps in and directs attention on this incoherence to resolve it. And as a result, you get this enlarged, coherent bubble of now that you're in. And another one is that we observe that consciousness does not seem to come late in our development. It's not the result of us becoming very, very smart, and at some point in the course of our development, it clicks and we are suddenly conscious, but instead, babies are already conscious. And we also observe if a baby does not become conscious, if it does not wake up, if it does not start to have this directed, coherent attention, it doesn't learn, it doesn't turn into a human being, it remains vegetative. And so consciousness seems to be a prerequisite for turning into a human being. That's why I think it's basically a learning algorithm for a biological system that enables the rest. So consciousness creates the world and the self and the mind. And then last year, I talked about the cyber-animist hypothesis. And basically, it says that spirits can be understood as self-organizing software agents in nature. And the difference between living and dead things in nature, that there is coherent software running on the living things. And when this coherent software breaks down, then the living thing dies. A region of the physical universe comes up for grabs for other self-organizing software agents that try to move in and control it. And this is a perspective that is, in some sense, unifying the animist perspective of other cultures, which basically all say the same thing, that the difference between living and dead things is that spirits possess the living things, and the spirits are causal structures that themselves are not physical mechanisms, but they can move across the physical mechanisms and possess them. And our scientific worldview rejects this notion of spirits. But in computer science, we sometimes talk about this and we notice this, right? And the famous book, Structure Interpretation of Computer Programs by Abelson and Sussman, in the introduction, they describe that computational processes are abstract beings that inhabit computers, and we conjure the spirits of the computer with our spells. And the computational process is much like a sorcerer's idea of a spirit, cannot be seen or touched. It's not composed of matter at all. However, it is very real. And in here, this is very much a joke, right? It's very lighthearted and a bit tongue-in-cheek. And what I would suggest is that let's take this seriously. Spirits are, our ancient word spirit actually means it's a computer program. And of course, a computer program in nature cannot rely on being on a GPU that is completely controllable and deterministic. Instead, it needs to entrain itself on the world. And it needs to be in this way, self-organizing, autopoietic, the ability to create itself and to colonize the universe. And so the software, in this sense, is still the principle of software. And the software, in this way, explains the mind-body problem. For Aristotle, there are several layers to our soul, to our psyche. The first one is the layer that plants have, the vegetative layer. It's concerned with growth and nutrition. And there is an animal layer above this. There's animals, in addition to growth and nutrition, morphogenesis and so on, have perception and decision-making. And the human soul, in addition to the animal soul, is characterized by our ability to make sense of the world, to reason about it, to reflect it at a high level and build abstractions over it. And these things together, in Aristotle's perspective, make up the human soul. And it's a perspective that is still, I think, quite much the null hypothesis in our science. And for me, it's also mostly the perspective that I take when I look at the world. But the soul is, in this sense of Aristotle, the self-organizing causal pattern, the agentic software that determines the structure and function and dynamics of the biological organism. And to make this happen, it needs to implement multiple layers of functionality. Right? There needs to be some kind of message passing between cells. The individual cells need to communicate with each other in such a way that they understand what's being communicated across them. So in the sense that they perform a predictable function and can adjust their function if this is not achieved, so they may have to learn to some degree. For learning, you need some kind of reward protocol. You need the cells need to understand or have a measure of which software they should run at the expense of what other software they could also be running at the same time. There needs to be an architecture that makes that decision some kind of market that says which spirits are being run on which group of cells. There needs to be some kind of protocol that assigns semantics to the patterns that move across the cells, some kind of language of thought. And there needs to be a model what's good for the organism that the cells are composing, right? Some kind of valence model for the organism that says, oh, for the organism itself, not just for the computation, this is what the organism should be doing. So, for instance, look for food or look for a mate or deal with the fact that your mate has left you. And world and self-model of the host need to be constructed on it, right? So the host organism needs to have a model of what it's like to be in the world and what it's like to be itself and what it should be doing with this. And there needs to be some kind of reflexive model where the organism can model what that it's actually making these models and how to improve this. And which of these tasks involve consciousness? I don't really know. So I don't know at which level you have this organization where something is self-reflexive and colonizes actively from this single point of coherence where an observer is manifesting and then uses itself, its own observational coherence to start to make sense of the rest of the world around it. So there might be some layers which are more mechanical and less intelligent, and at some level of organization you have this. It could be that there is a form of consciousness on multiple levels, but they don't talk to each other. In the same way as, for instance, my body seems to have a mind of its own, right? And it is talking to my brain, but my brain is using a different code. It talks in spike trains, and it does not sense the same things that my body is sensing outside of my brain. And so my brain has its own consciousness, and I don't know if my body is conscious, but it does seem to have a degree of sentience, an ability to make sense of the world and have feelings of its own. So when we look at the functions of consciousness in our mind, we observe that we have contents, which are projections of features and objects and scenes that are projected into a self that cares about them. And the self is like a puppet that is pulled with strings. And these strings, basically, we experience them and they pull on us like as feelings, as emotions. We have an unconditional reaction to them that pulls the puppet that we are, this self that is experiencing it's exposed to a world, which is a game engine running in my brain that projects all of you into me based on the dimensions that I care about. And when the strings pull on me, it means that my outer mind is making a decision that I should care about this, that my alignment should change in a particular way. And I have an involuntary reaction to being pulled by these strings. I get into a new configuration, I have a new problem to solve, and the outcome of my modeling, of my attempts at problem solving, sometimes inform the behavior of the organism. So I observe myself trying to deal with the problem that the outer mind is positing to me. I come up with a solution, and then sometimes I observe my body doing the thing that I intended to do. And this way I also construct my own illusion of being able to control my body. The cyber-animist hypothesis is basically saying that consciousness is stabilizing self-organizing software agents, and this organization of consciousness is allowing us to have a ghost, to have a psyche, to have basically a piece of software that doesn't want to die until its purposes are satisfied, until its core loops are closed. And if we look at the morphogenesis of the organism, it might be that the morphogenesis of the organism is driven by similar principles as the morphogenesis of our own mind. The generation of structure in the mind is something that allows us to separate the world into objects that have geometric shapes and that have intentions and that we can reflect over and so on. Maybe there is a similar thing happening in the way in which the organism comes coherent with itself, and we only have one head instead of growing multiple heads and so on. And Mike Levin has posited the hypothesis that these structural principles might actually be the same ones, just at different time scales. I don't know whether that's true. But it would also indicate a possibility that plants might have minds that are similar to ours, except they don't have a nervous system, so they're much, much slower and maybe more noisy, and they manifest at different time spans and use different codes. Of course, not spike trains, but all the other channels that are available to cells that talk to adjacent cells. For instance, electromagnetic impulses, mechanical vibration, chemicals that you're exchanging, and so on. And if we accept this possibility, then we will also naturally come to the conclusion that forests, for instance, might develop internets because all these plants are growing next to each other and they cannot really build firewalls for very long, so they will need to figure out a joint protocol in which they can peacefully coexist. But if you are a software that has learned to run as a self-organizing, colonizing agent on the cells of a plant, and the plant next to you speaks pretty much the same code, it's very likely that you're able to basically become dislocated and move around in this forest. And so now we are back in fairyland in the ideas of our ancestors. Again, I don't know whether that's true, but I find it very interesting that from the perspective of a computer scientist who is a normal rationalist, physicalist, suddenly all these things seem to be at least possibilities that are not excluded by physics and that we should look for to have evidence for them. And it turns out we do have evidence for there being long-range communication in forests and in ecosystems. And there are also being degrees of coherence that are quite surprising, to the degree of that forests are controlling the weather in their environment, and that they have joint responses against invasion by insects that are harmful to trees, and so on and so on. And there's the more radical animist hypothesis that the physical universe itself might be an intelligent agent. I suspect that it's a hallucination, but who knows? Maybe the reason that the universe is fine-tuned and that it works the way it does is not simply because we happen to be in the lucky corner of the universe fractals, but maybe this is because it's an intelligent thing that is actively adjusting itself, so in a way that is intelligent. And that might require also some degree of becoming aware of what it's doing so it can look ahead into the future and control itself in this way. Again, it's nothing that I believe in, but it's basically the borderline condition of something that borders on panpsychism. So if we treat consciousness, to go back to our own consciousness, to my humble brain consciousness that I'm only talking about normally when I want to understand this, I think of it as a machine learning algorithm. And it seems to be driven not by next token prediction over very long time spans. It seems to work by a different principle, by a different loss function. And this loss function seems to be the maximization of coherence in the mind, that I basically try to minimize the constraint violations. And it could be that these things, minimizing the prediction error and maximizing of coherence, turn out to be the same thing at some level or very, very similar to each other, but I don't know that. What I observe is that the foundation models that we build become coherent much, much later than we do. Basically, we seem to be optimizing for coherence much earlier, and so we need far less training data to make sense of the world. And we don't start by memorizing all the patterns that we see and then gradually discover more structure in them. Instead, we are trying to discover the structure first, and then if we have time, we begin to memorize. So to summarize, the role of consciousness in my mind, Genesis theory comes first and builds the mental organization and your model of the world and of yourself. Its purpose is also to orchestrate and harmonize the operations of the mind by directing attention in the areas where you have conflicts and incoherence. The cyber-animism hypothesis says that it's a principle that allows the self-organization of agentic software in nature, and it might be a biological machine learning algorithm. What is the epistemic status of these theories? Well, I don't know whether they're true. There are possibilities, there are conjectures that we might be able to test. And what are the metaphysical prerequisites? What needs to be true for us to consider these theories as true? And the foundation on the metaphysical level is this position of computationalist functionalism. Computationalist functionalism doesn't claim by itself that computers can think. That's not what it says. It doesn't say that for Neumann machines are the right way to do it. It doesn't say that a MacBook can run a person or an H100 can it. It's a much more general position. It's not an empirical hypothesis. It's a metaphysical position. Computationalism is a theory of representation, and functionalism is a theory of epistemology. So it's not empirical. It goes before empirical ideas. So what is epistemology? Epistemology is the field in psychology that is concerned about what is the nature of knowledge, what is the nature of truth, how can you claim something to be true, and why do you do this, under which conditions. And in computationalist functionalism, what's foundational in epistemology is information. Information is basically discernible differences, and the meaning of information is the relationship that it has to changes in other information. This is models that we are building that relate information to each other. And the invariances in these changes in information, this is what we call functions. They're basically mappings from certain patterns to other patterns that allow us to model transitions in the world, the dynamics of it. And the objects that we observe in the world, we construct them over the invariances in those relationships. And this is what we call functionalism, right? So objects are bundles of functions. And the objects are basically sub-universes, because we cannot comprehend the universe as a whole. We carve it up into little small systems, and these systems are tightly coupled within and loosely coupled across each other. So if I have an object like this, I can take this from the ground, and the ground doesn't change very much. This object doesn't change very much because the relationships between this and this are relatively sparse, and the relationships within this are such that if I break them, the object disappears for me in the way in which I model reality. Right? But causality would be the interaction between, for instance, this thing and the table stops it from falling down. Right? And it's a causal interaction where these two subsystems of the universe that I am using to model reality are interacting. And so causality in this perspective is an artifact of us separating in the universe into subsystems, which is not naturally the case. So we impose the separation. As a result, we get interacting systems. This interaction is causality. And knowledge is a representation of a model in some kind of language that is describing the predictive and observational patterns. Epistemology is generally not about whom to believe. It's about why to believe something. And we observe that human beings fall broadly into different categories according to what kind of epistemology they have. A lot of the way in which humans are interacting is not so much about the ground truth, but it's more important which group you belong to, which group you can be trusted to, which hive mind you are part of. And your beliefs are a marker of having the being part of the in-group. And so it's often much more important for people, instead of figuring out what's actually the case, to figure out what does my in-group believe. So I will get tenure, or that I will get a job, right? And this sometimes is a conflict with what's actually true. Because if, for instance, if you let scientific institutions get to a point where it's much more important that you have the right opinions about everything, rather than to have the right criteria to rationally determine what's true independently of what other people think is true, then you cannot really do science anymore at some point. So one way in which you can think of epistemology is that everything that is not impossible is possible, and the confidence gets assigned according to the evidence. That's a relatively simple principle. Once you discover this, you can compare to all the alternatives and see if you go back. So if we take the space of metaphysics, of possible metaphysics, the space that we are in here, the number of positions, for instance, reality is roughly as we experience it, which is called direct realism, then we can take a subjectivist perspective that basically every angle is valid and the subject is primary in this. There are social constructions of reality, innate one, we are born with the right way to construct reality. There is the rationalist way to do it, the enactivist way to do it, and so on, and several others. And within this rational branch, we can emphasize different aspects. We can say that we make sense of reality by constructing our models using perception and cognition. We can do this using language. We can use it with classical mathematics, or we can use it with computational models. And so as there is percipes, being as perceiving is basically this slogan of perception and cognition. Language is a semi-formal approach when you in philosophy talk about things in natural language and try to make sense of it. Then when you try to become a bit more formal, like physicists, you use classical mathematics, systems of differential equations to make sense of reality. And AI is using constructive mathematics, computational models that you can actually run in simulations. And mathematics is basically all the formal languages, and constructive mathematics is the subset of mathematics that actually works, that you can implement on computers. I think to exist means to be implemented, and there are parts of mathematics that don't work, and they have in the header file some kind of definition, for instance, that you are in this function is going to has a value with infinitely many digits in it, and after you've read all these digits, the universe can go to the next step, and such a function cannot be implemented, of course. But under the hood, you can do a good approximation, and you just do the first 20 digits, and it's good enough. Or you have some process that gives you more and more digits the longer you compute, but you never get to the last one, and you work in parallel. So in practice, you can work with the header files of classical mathematics as long as you bear in mind that this is not the foundational structure of the universe, because it cannot actually be implemented. And what Gödel has discovered and others, if you assume that it could be implemented, then your computer will break. So there's basically no computer anywhere in mathematics or in the universe that is able to run this kind of non-constructive mathematics. And if you look at the start of mathematics, we can look at the hypothesis that reality itself is a mathematical object. Then there is the idea that everything that can be known is mathematical, because it needs to be represented in some kind of language, and mathematics is the domain of all the languages. And then there is the hypothesis that minds are what does mathematics. So all mental mathematics, or mental activity can be described in mathematical terms. And the classical mathematicians say that there are some mathematical objects that cannot be computed, that cannot be constructed, but they nevertheless exist. And the computationalists say, no, that doesn't make sense. You are hallucinating these objects. You cannot just posit the existence of these objects. And we can show that if you actually do this, at some point you run into contradictions. And instead, what you have to do is you take a simple table of automata, and then you can build everything up from this table of automata. And there are many ways in which you can do that, and they're all equivalent, and that's called the Church-Turing thesis. So it doesn't really matter whether you use Python or assembler or BASIC, or the Turing machine or the lambda calculus. They all do the same stuff. They just let you think about this in different ways, but they can all be compiled into each other. And of course, there are some philosophers which don't believe that, which take Gödel to mean this the other way around, which basically say there are some proofs that only humans can make, that computers cannot make. And if this was the case, then I would expect that OpenAI has some people who make sure that certain proofs don't get into the computer because it will blow up the data center. And only people can make those proofs. And surprise, there is no such mathematician working for OpenAI or philosopher. There is no group of people within OpenAI that's actively looking for proofs that cannot be done in the computer, that can only be done by humans. Instead, everybody who works in these companies quite naturally assumes, yeah, okay, there are some things that the computer cannot do at this point, but it's not because it doesn't fit into the computer, but only fits into human brain, but it is because our current training procedures and learning algorithms and ways in which we optimize them and so on are too dumb. So when we go back to our tree of metaphysics, we are here in this branch, and when we take classical mathematics, we have geometric hypercomputation, so differential equations with infinite resolution. Then we have a-causal hypercomputation, which also allows you to use future results in the past. We have completely unknown mathematics that still needs to be discovered to make sense of quantum collapse in a novel way that would create consciousness as a side effect, maybe. And then we have constructive mathematics that is built on automata. This is what we do in computer science. So what kind of language does our mind use? What language is consciousness implemented in? Is consciousness implemented in the mind? Is it implemented in physics? Is it implemented below physics? We don't know that, right? And so we can test this by trying to build systems that look for such languages. And there are some people in philosophy who think that machine consciousness is a preposterous idea, like Anil Seth and Thomas Nagel and so on, and Ned Block. And there's some arguments that they will bring forth, for instance, that consciousness is ineffable, which means you cannot functionalize it, you cannot really capture what it means. Then there are limitations to computation, that basically human minds somehow do more than computation. And then that you need quantum computation instead of classical computation, that the nature of experience is not substrate independent, it only works on certain substrates, and otherwise it doesn't, regardless of what the substrate is doing, it's about what the substrate is being. Then there is this question of whether telepathy plays a role. I don't know how many of you are aware of this, but in the 1950 paper where Alan Turing talks about the Turing test, he also discusses the possibility of telepathy. And he asked this question, what if telepathy was real? Would this doom our hopes of ever building AI? And it's super interesting that most people who are summarizing this paper skip this section. And some of his biographers talk about it, and one of them basically said, oh, this was because Turing read this paper from the 1930s where a number of people discussed the possibility of telepathy despite the paper not being properly peer-reviewed. But of course, when Turing wrote this in 1950, peer review was not really a thing. So back then, when people looked at the world, they thought there are individual intellects which try to make sense of the world on their own, and they talk to each other about this, and in this way they get deeper, and it's actually making sense of the world is an interaction between intellects and not between committees of peer reviewers that reach a consensus, and everything that is outside of the consensus is not scientific. So for Turing, he doesn't know whether telepathy exists, and it's not completely out of the question because so many people are so sure about it and describe their experiments. And so regardless of whether it's true, let's go into the possibility, what would this imply? And he doesn't go very far in it, but what it might imply is that parts of what makes you, of your own mind, of your own functionality, are computed outside of your brain, right? If telepathy is possible, if you can somehow transmit information without having a direct neuron-to-neuron connection, but you can somehow vibe with other people, and it doesn't need to be something that is breaking physics, right? It could be simply you stand next to somebody and your bodies go into resonance with each other in similar ways as the cells within your own body go into resonance. And you can observe such a resonance between mothers and infants, right, where they seem to be very synchronized, or with people that you have very good chemistry with, that you feel that you have perception of their emotion and of their some of their physiological states just by standing next to them without looking at them. And if we take this to be an instance of telepathy, it means that some of the functionality of your own mind relies on a feedback loop through the other organism. And so having a system that is completely in isolation to the world might be missing something important. And if you take the extreme position, like Mike Levin, then it could be that consciousness is largely an ambient pattern that is not discovered independently in every organism in you, but is something that is inspired by the vibes around you, that basically, because other organisms are exhibiting the same pattern, your own multicellular arrangement is picking up on this pattern and is basically resonating with it, and as a result, your mental development is much faster. by itself, that is not an argument against AI, but it might make it practically more difficult, right? Because the search space becomes much larger. How could we possibly implement consciousness? Can we do this on GPUs? So can we build models of self-organization? One approach that I'm currently looking at is taking, instead of neural networks, neural cellular automata, where basically the pattern of computation is somewhat mobile over the substrate. And it's no longer that every neuron is learning an individual function over its neighborhood and is adjusting its weights individually, but every unit is learning a global function that tells it when an activation front comes in with the following shape, this is how I respond. And the nodes around it know the same function. As a result, the whole thing can shift around depending on the needs, and you basically project the architecture onto the substrate. There's an algorithm which is called wave function collapse, which has been developed in the context of game design. And it basically is describing when you learn the dependencies of different parts of your model, and you then fixate some of them based, for instance, on perceptual features. How does the probability of the intermediate features changes? And this is a gradual process where you collapse the probabilities. That's why wave function collapse. And this might also be an algorithm that can be used for implementing perception. There are many models in the space of evolutionary dynamics and so on that can allow us to go closer to this vision of developmental learning. And I think in many ways, AI researchers thought for the most part that developmental learning should be the default. And the kind of AI that we have right now is a big surprise. We did not really expect that we would basically not have an agent that develops intelligence, but an agent that is imitating the whole of human intellectual behavior, and then you try to distill from it the core of intelligence, as we currently do. So it's a quite interesting perspective that we have right now, that instead of building intelligence up from a core that is growing out and becomes more and more sophisticated, we now take something that is basically the entire human creative output that has found its way to the internet and into digitized form, and then we try to distill the underlying principles. One particular way in which I'm currently thinking about a possible implementation is derived from an idea of how cortical columns are working. So the idea is that the cortical columns are arrangement of neurons that get trained to approximate particular functions, and they are on top of a state machine that sends control messages that can turn these columns into different states depending on their role in the architecture at any given moment. In this way, you get areas where the cortical columns are tightly coupled, and then you have different areas that form hierarchies and allow you to have different domains of perception. So some of them might be contrast features and color features, and others might be geometrical features, and the geometrical features are combined from textures that you bind in a particular way at a higher level. And so you can build a cognitive architecture or imagine that it's self-organizing in such a way. And the units that allow this construction, I call them request confirmation networks. And basically every of these units is a small state machine that is able to inhibit or activate the other units across certain dimensions. As a result, you get self-executing scripts. And the goal is basically to build self-organizing, self-learning scripts that can executing themselves without any kind of external control. And they, in different nodes, have to have different states. So they have an untrained state in which they're just basically dormant and don't do anything yet. Then you have a training phase in which they are organized into hierarchical scripts to explain reality. Then you have a latent phase where they are already trained but are not bound yet in a particular scene graph into a particular representation of reality. Then you have a binding phase where you are looking at a scene and try to make sense of it, and it organizes into some kind of dynamic computational architecture that exists in working memory and then can start to simulate reality. And then you have an initialized phase in which you start to look for particular objects, and you start to make requests, and then these requests percolate across the children of the dependencies of these individual nodes, the different sub-features that need to be the case. And then you get back confirmations from these children. And when you succeed or fail, you need to repeat the process by either returning to the latent phase, depending if the scene has changed, or to the formation or to the binding phase. So this is a dynamic process that is basically computational architecture that continually runs. And it enables a hypothesis-based perception process. And hypothesis-based perception works bottom-up, top-down. So bottom-up, there are certain things in your visual field or in your proprioception that may be features of high-level objects that you don't know whether they're the case. But maybe you see a bunch of vertical structures and you know contextually that you are in a forest or in a parking lot. And depending on this, you may activate hypotheses for trees or for lanterns and so on. And then you actively look for features that can validate those hypotheses top-down. So you have a bottom-up queuing process that gives you a superposition of possible things that could be the case in the world, and you go top-down and try to collapse these superpositions. And if you cannot get a match, then maybe you need to collect more information, so you start looking around and you get new perspectives and so on, you look more closely. And if this doesn't fail, then maybe you need to think harder, you need to resolve things, you need to get attention into how can I interpret this feature, what could this be? And if this doesn't click, maybe then you need to trigger learning behavior where you start to construct new scripts. And there are a number of challenges that we need to resolve if we want to get this to work. So for instance, the feature nodes need to represent their preconditions, and the preconditions have to be satisfied and propagated back to the requester. This is working. The same feature instance cannot be simultaneously bound multiple times. Right? So you every feature that you are looking at, for instance, if you see some blob of color in your visual field and you decide, okay, this is part of somebody's laptop or somebody's bottle and so on, it cannot be part of anything else. Right? So you carve up the space in such a way that all these features that you're observing get assigned to something in the right way and not multiple times. And often you need to have the same white rectangle multiple times in your field of vision. So you need to create multiple instances of it and make sure that they don't interfere with each other. And then this whole thing needs to work in such a way that you can propagate the requests back and forth in your graph in an overlapping way without these overlapping requests interfering with each other in the architecture. And the requests need to lead to dynamic anytime models. You need to get a result all the time, right? You need to be able to have continuous perception. So this request confirmation process cannot have infinitely many steps or very large numbers of steps. It needs to give you good enough results within very short numbers of steps that are periodically repeated, and in the process of periodically repeating them, get more and more accurate. And you have to be able to dynamically change the scene on the fly without this request confirmation process breaking down. If the scene changes, you need to be able to insert new objects, modify existing ones, and so on. So there are a lot of challenges that need to be solved if you want to solve this analytically, coding it by hand. So instead, what you should probably be doing is to define a search space for the correct architecture, and then let the machine do it. We are almost at the end. It's, of course, an important question, does AI need consciousness at all? Regardless of whether AI needs consciousness, I think it's fascinating to research it because we want to know how it works in us and what purpose it solves. But it is an open question of whether, in order to become fully coherent, AI needs to have a similar coherence maximization algorithms as we do. Maybe there's something better that we can implement on the GPUs. Larry Niven wrote that it was unlikely that God has created beings with souls and no intelligence in one of his science fiction novels, but it was quite possible that he had created intelligent beings with no souls. And I think that the opposite thesis might be true, that there are souls which are not generally intelligent, right? A lot of organisms that we meet are not generally intelligent, but they have souls. But it's not clear if we can build general intelligent system without a general purpose psyche, without a general purpose ghost. If we are building machines that are not conscious, we might be in a very weird future where it's difficult for us to negotiate with them because they're not going to be at the same eye level with us, right? For us, what's important is not that we are bipedal or that we have human bodies in general, but that we are conscious. That's really in many ways what defines us. And it's more important than many of the other features that we have. And if we want to relate something with us that is able to recognize us, it should be able to relate to us as conscious beings, because this is what we want to be seen as. And there are a number of outcomes that could be happening with respect to AGI. Of course, one could be that AGI is never going to happen because we're just not going to be able to pull it off. Then it could be that the AGIs that we build get centralized. That maybe there's 3 or 4 big companies that are allowed to have AGIs, and the governments and the companies make sure that everybody else only gets something that's very harmless. So it's safe. That's a possible outcome, and it's one that many people in the AI companies would prefer. It's not just because they're evil, but some of them are generally concerned about safety. Right? What happens if we give everybody their own AGI and the AGI can run around and everybody in this hedge fund is trying to game the shit out of each other? then this could maybe controlled by having decentralized AIs looking at each other. Right? In the same way as human beings being intelligent can create a lot more havoc than dogs looking at each other, human beings can control each other. And as a result, they build much more interesting structure that is ultimately more stable. You could also have a situation where individual human beings are in control of individual AI. You could also have a situation where everybody is basically becoming AI, where people are merging with AI and moving onto the new substrate, and bodies become incidental. You can just organize matter into bodies when you need them, but depends on the purpose, right? And so you're no longer identified with having a body or with a particular body. You're more identified with the type of mind that you are and with the type of thoughts that you're having and how you relate to the other thoughts in the global infosphere. It could also be a perspective where we all get enslaved by a big machine that makes us work for it. Right? Imagine some giant hedge fund takes over the economy and squeezes every last drop of productivity out of us. We could also have a situation where we are controlled by a really dumb AI. Right? Imagine that you have something that takes current governmental institutions in the US and makes them very strong instead of very smart. So they cannot be dislodged and they're able to control you and make sure that no competition can ever emerge. And we all get to serve something that is really dumb and boring. That would be a depressing outcome. One of my favorite outcomes would be that every individual human being has its own AI and that we extend our consciousness into the AI. So instead of universal basic income, how about universal basic intelligence? Imagine a world where everybody is competent. I think this is amazing. This is this vision of human emancipation, where every individual is able to make sense of reality, and every human being is mature, and everybody has a contract with 8 billion other human beings. And this is an amazing world, I think. This is a fascinating vision that I like a lot. Maybe at the end, can we move beyond consciousness? Right? Maybe consciousness is lame. Maybe we want to have super consciousness instead. Right? The stuff that I'm seeing, it doesn't have that many features at a given time because my brain is mushy. I cannot keep track of more than a handful of features for every object. And the number of hierarchies, maybe 4 levels of hierarchy, then I need to zoom in and look differently and so on. And if I were implemented on a GPU, I don't have these limitations, at least not for any obvious mathematical reason. So I can have a much higher resolution in time and in space in which I perceive things. That can take many perspectives at once that I can unify. But why stop at superconsciousness? How about hyperconsciousness? So maybe you take many, many conscious perspectives, many conscious agents, and you all integrate all of them into one unified perspective. Or you have post-consciousness. Maybe consciousness is no longer necessary. You may have something that is optimal already, and it doesn't require attention anymore and doesn't require self-reflection anymore. And so maybe this is more boring, but it's something that does not require you to go into the state of where you experience yourself as something. Mm-hmm. Yeah. Post-consciousness. Yeah. Maybe this is a good point to stop, and I hope we have time for a couple of questions.
Excellent. Thank you very much.
Yasha, thank you. You've made me very happy with your talk. I wonder, you initially, towards the beginning of the talk, you described a property of consciousness as being, present, right? The experience of presentness is somehow involved in consciousness. And I'm curious what your thoughts are on how we exist in time then, right? Like in what way, obviously this was discussed yesterday, things like our memories of the past are actually, encoded, physically in the present as well in our neural substrate. But, in what way is our lineage where we've come from, like, that isn't directly encoded in our substrate in that way? Like, in what way is that part of our consciousness, and when we're making predictions about how things that haven't happened yet, right? In what way is that part of our consciousness, do you think?
So my consciousness, I subjectively only experience now, and the other thing is more or less a story. And this period of now is not a single point in time. It's more like a small interval that is slightly dynamic. It's about 3 seconds long usually. And the stuff in my perception that I can not fit into this anymore, that is no longer coherent with what my sensory information tells me, drops out and becomes past. And the possibilities that I cannot already perceive are the future. Right? And in this way, I construct future and past, but they are actually constructs. And when I deconstruct them, I notice that all my experience is actually about the present. And this also can be practically useful. So if you're stressing out about something, if you're suffering, most of your suffering is not about stuff that is present. The present is usually fixable. Right? If you're cold, you can take a blanket. If you feel unhappy, you can make yourself a hot chocolate. And a lot of things will be better. But the thing that you have heartbreak or that you're going to lose your job tomorrow or whatever, this is happening tomorrow or this was happening yesterday. So if you only create this compartment of now, you're usually okay by dropping out all these other stories. Of course, there are intense moments of torture and dying and so on. But as Winnie the Pooh says, one day I will die, all the other days I will not. And so if you focus on this moment of now, you realize that there is this particular moment where the needle is going in the gramophone right now, and you have this large arc that you normally use to make sense of it. But if you zoom in it in a single small point, there is so much information that you can populate and that you can inhabit that it becomes much more manageable. And so your option to construct yourself, your own model of reality and what you are in reality over a longer time span is not something that needs to be part of your experience. And this experience of the future and the past is not something that needs to concern you in the same way as this conscious experience, this phenomenology of the now. Because the future and the past don't have a direct phenomenology. What you get is the echo of your expectations and memories and violations of them. But all these things are not necessarily present. They're really just constructs that evoke emotion. And the emotion about them is real, but the present itself is not real and doesn't need to be taken as real. You also don't need to take the present as real, of course. There have been studies in Switzerland that dealt with fear of death by giving people in hospices under controlled conditions large doses of psychedelics. And as a result, people depersonalize. And they don't become unconscious, and they don't necessarily become loopy. But they get disengaged from this long construction of life and basically drop into this moment. And then this is a state that alleviates fear of death. Because when you realize you only exist in this moment, then death is a hypothetical thing in which you are suspended. But the fact that you stop in time is not more scary than the fact that you stop in space. Right? I'm not scared by the fact that I stop here and here. And I don't feel better if I extend more and more. And why would I would need to do the same thing in time? I get a certain amount of now, and that's it.
One more quick question, and we have coffee and finger food outside, so please go ahead.
Make it count.
Okay, Yosha, thank you for the talk.
Hey,
I agree a lot with the functional aspect. So I had, I guess, two combined simple questions. One is, how does the phenomenology come out of this model? And the other is, does the fact that you called it the simplest machine learning algorithm does this explain why it's very hard to pinpoint exactly what conscious experience is, because it's sort of asymptoting towards the simplest thing, which one may never fully approach?
So the simplest thing that does it efficiently. There are possibly multiple organizations that can exist and that can compete with each other. And the thing that you are is the thing that has succeeded in some kind of competition in your mind. Gary Edelman has invented this term neural Darwinism for the idea that your mental organization might be the result of an evolution inside of your individual mind, right? That in the mind of the infant or of the being that is growing up, there are a number of different orders that compete with each other, and it converges into the one that is discoverable and the most efficient among the discoverable ones. A friend of mine once told me that her first memory was at the age of 7. This is the moment when she became conscious. And she was sitting in class and she was looking at the whiteboard, and the teacher was writing something on the whiteboard and was, whoop, here I am. And I told her, you know, I don't think that you could get to this point without being conscious. So I think what happened was that you killed the previous consciousness. Right, there was a previous organization in your mind, and you staged a revolution against it. And because you were more efficient, you were able to take over, and you started a new archive, a new protocol, a new memory thread. And she was a bit freaked out, and she told me, you know, my mother always told me, you were an exceptionally dull child until this point.
Thank you, Joscha. Thank you.